Hi, welcome back to class. Today, let's see the differentiation of quotient of function, also known as quotient rule. We'll start by deriving the formula and then we'll take an example that can help us understand it better. That said, let's get into class. Now, a good way to envisage your quotient of a function is y is equals to u over v, where y, u, and v are functions of x. They are all functions of x. Now, if there will be an increase in y, obviously there will be an increase also in u, there will be an increase in u, and also there will be an increase in v. So we'll call this our equation 1, and we'll call this our equation 2. Now the next thing is to subtract from what we saw when we were dealing with differentiation from first principle. Next thing is to subtract equation 1 from equation 2. So that this becomes y plus change in y minus y will be equals to u plus change in u over v plus change in v minus u over v. Now I can write this taking an LCM. This will become v into v plus change in v. This is change in v. So that v plus change in v I'll be left with v. Then the numerator becomes v into u plus change in u minus v here now, I'll be left with v plus change in v. That will be u into v plus change in v. Now, I've just rewritten the equation so that this, expanding it, will have v u plus v delta u minus u v now minus u delta v all over v squared plus v delta v. Obviously, I have vu here, I have vu here. It's the same thing. Then my delta y will be left with v delta u minus u delta v all over v squared plus v delta u. Now the next thing is to divide both sides by delta x. So that will be equals to v delta u minus u delta v all over v squared plus v delta v into 1 over delta x. I can easily rewrite this to be the same thing as v delta u minus u delta v. This is over delta x minus delta x, everything over v squared plus v delta v. Now, as delta x begin to tend to 0, we say that our delta u also will obviously tend to 0, delta v will tend to 0, and delta u delta x will tend to du dx, and dv delta x will be equals to dv dx. Delta y delta x becomes v. In place of delta u delta x, it becomes du dx minus v minus u dv dx over v squared. Obviously, delta v and u becomes 0. So that gives us the quotient rule. Quotient rule says that this is delta sine x over x squared. That is, our y is equals to sine x over x squared. So that u here will be equals to sine x and v will be equals to x squared. If u is equals to sine x, obviously your du dx will be the same thing as cos x. And if v is equals to x squared, our dv dx will be the same thing as 2x. Remember that if y is equals to a x raised to power n, our dy dx is the same thing as a n x raised to power n minus 1. Let's apply quotient rule here. Quotient rule says that if y is equals to u over v, dy dx is equals to v du dx minus u dv dx over v squared. My dy dx will be the same thing as v. My v is x squared. That will be x squared into du dx. My du dx here is cos x minus v, that's sine x, into dv dx. My dv dx is 2x over v squared. V squared is x squared over x squared. V is x squared all squared. Now, so that we can simplify, my dy dx will now be equals to, I'll factorize with x cos x minus 2 sine x all over x raised to power 4. X here is 1, x here I will left with 3. Conclusively, my dy dx is the same thing as x cos x minus 2 sine x all over x cubed. With this, I hope you understand how to treat quotient rule. Thank you for staying with us and see you in our next class.